Okay, so from the video, we have learned about Gauss law and then nato siya duha ka examples pod no. Two examples followed after the discussion. Okay, so in order to um, know Gauss law better, let us start with the discussion on electric flux. Okay, so as an overview, Gauss law is another method of calculating or determining the electric field of a collection of charges or pwede pod charge distribution. So it is somewhat simpler, but it is not dili siya nato pwede magamit for all systems, no? Gauss law can only be used for several systems that has high symmetry. Okay? So, many nga slide. Okay, so in the previous chapter class, we have discussed about electric field, and we know that all charge objects emanates electric field. Tanang charge object class kay makaproduce og electric field, and it can be quantified. It is equal to F over Q, which is equal to Q over R squared. Okay? And then if we have a charge distribution such as this, so this is a line charge, kung ano, if we want to know the electric field at a point, say for example at this point P, then ang atong buhaton is magkuha lang ta og gamay nga portion ani nga line charge, and then kuhaon nato ang ang electric field. Okay, so this small portion has a charge dq and it has a length of equal to dl. Okay, and then take note that dq is equal to lambda dl, where lambda here is the line charge density. Okay, so you can get the total electric field due to this kining whole configuration of charge if we integrate dE. Okay, so to integrate dE, you have this one. And as our experience suggests, so ganito medyo taas ang calculation, no? So, good thing kay naay table of integrals. But kung walay table of integrals, mano-mano ta nga mag-integrate, then it would take a lot of time. Now, here is Gauss law. This is another method of calculating electric field for some configuration of charges. Okay. Okay, so on summoning electric flux, we start with the definition of electric flux class. So the electric flux, denoted by this Greek letter phi, capital letter nga phi, is equal to the dot product of the electric field and the area vector. Okay, so we define an area vector that is always normal to the surface. For example, class, you have this one na kay area, na kay surface na gina-consider such as this. And then, it is vertically oriented. So, the area vector is perpendicular to this. Okay? So, it can either be padulong diri or padulong dito sa likod. But, so, pwede ka mag-set no kung asa imong area vector padulong, but you have to be consistent with it. So, kung diri mo ang area vector, then you have to be consistent nga diri siya always. Alright? So, electric flux is the number of electric field lines passing through a given area. So, kinino, ipon lang nimo ang number of electric field lines that is passing through this surface. So, muna siya ang flux. Okay, so, since flux is a dot product, so ganito ang answer sa dot product class kay a scalar quantity. So, electric flux is a scalar quantity and it is equal to E times A multiplied by cosine theta, where E here is the magnitude of your electric field and A is the area. And then this one, theta here is the angle between the electric field vector and the area vector. Okay, so you have this one. So the flux through some surface is a measure of the number of field lines passing through that surface. Okay, so the flux, as you can see from this equation, flux is dependent on the electric field strength. So the greater the electric field strength, then the greater is the flux. And then we have the area. So it is dependent on the surface area and also of the relative orientation of the field and the surface. Okay, so it is also dependent on the theta. Okay, so kato no atong example class kay ingani vertically oriented siya na what if tilted ang imong surface. So this is a side view of your electric field and then your surface. Okay, so side view ni siya. Muna siya imong makita. Mula siya line but this is actually a surface. Okay, now what if this surface is tilted at some angle? Okay, now if the surface is tilted at some angle, then you have to consider, of course, the angle between the area vector and the electric field vector. Okay, so this is your theta. Muna siya imong theta class. So this is your electric field vector and then muna siya imong area vector kani. So the angle between them muna siya nga atong i-consider. Okay? Okay, so here is quiz. So calculate the flux of the electric field E through the surface A in each of the following cases shown. Okay, so here you have a vertically oriented surface and then your electric field vector is to the right. So as you can see, the area vector is also to the right. So we define an area vector that is directed to the right also, meaning to say your electric field vector and your area vector is parallel to each other. So the angle between them is 0. So again class ha, ang basihan sa angle kay dili ang sa ganito, dili ang direction sa imo ang electric field with respect to the surface. It should be the angle between the area vector. We define it as the vector that is always perpendicular to the surface. And then, kini siya ang electric field. Okay, it is between the area vector and the electric field vector. Okay, so here, phi is equal to E dot A and E dot A is equal to E A cosine 0. Since parallel man, no? The angle between them is 0. So, cosine 0 is just equal to 1. Therefore, for this case, the first case, phi or the flux is equal to E times A. Or you just have to multiply the magnitude of the electric field and the area. So, this is the case where the flux is at maximum. Okay? Now, here is case B, wherein the surface is lying flat and then your electric field vector is also directed to the right. Okay? Now, take note that the area vector is always normal to the plane or it is always normal to the surface. This means that nadire mong area vector. Okay? So, notice that your electric field vector and your area vector are 90 degrees apart or the angle between them is 90 degrees. Therefore, you have E times A cosine 90 degrees that is equal to 0. Okay? So, walay flux or walay electric field lines nga nakapass through sa imong surface. Okay? And then for the third case, you have unsa man ni? Ang imong area vector is this. Kanino since naka-incline or naka-tilt ang imong surface, then your area vector is at some angle with respect to your E. Your vector E is again going to the right. Okay? So, naani siya X component, napo di siya Y component, but as you can see, or as mentioned, katulang component that is parallel to the electric field vector ang ato ang makonsider. Okay? So, you have EA cosine theta. Since wala man gihatag si theta, so this will be our flux. So, theta is equal to EA cosine, phi is equal to E times A cosine theta. Now, here is another case. We can call this case D, wherein the electric field is going to the left or it is directed to the left. And then your area vector is naadiri sa right. Okay, so this is the case where the flux is negative. So although flux is a scalar quantity, it can be negative. And it will be negative if the angle is greater than 90 degrees. The angle between your area vector and your electric field vector is more than 90 degrees. Okay? Now, what if the surface is curved or the field varies with position? So, here is an example. You have a curved surface. You have here, atong buhaton ani class is, we have to divide the surface into small regions with area dA. So, in doing this, we can have a surface, kini siya no? Gamay nga surface that seems to be a plane or mura siya og kanang dili curve nga surface. Since gamay man kay atong gikuha, so it seems that dili siya curve. Okay? So this surface has an area that is equal to dA. Alright. Now, the flux through dA is equal to this one. So, since kini ra man nato i-consider, so napo na siya yung mga gamay lang po ang flux nga moagi mo pass through ang area, and we can label that or denote that as d phi, and it is equal to E times the area dA, and then cosine theta, where theta is of course the angle between dA and E. So kini man good class kay kung kini atong ang whole atong i-consider diretso, maglibog ta kung asa dapit ang atong area vector, right? Kay for example, diri medyo kanang sa paani kanang naa siya ingani no more siya hump. Okay? So mura siya og kung sa wave pa na siya kay mura siya crest. So lahi ang direction sa imong area vector diri compared kung napo ka diri sa murag boundary, no? So you have to divide the surface into small regions with area dA. Okay, infinitesimal area dA. Now, you can express this as E dot dA. So this small area here has a flux that is equal to E dot dA. And to obtain the total flux of this curve, you just have to integrate it. So, integral of d phi is just equal to the integral of E dot dA. Okay? So, integrating that, you will have phi is equal to the integral of E dot dA. Okay? Now, in the case of a closed surface, you just have to add this kini siyang ring diri to indicate integrating this over a closed surface. So, examples of a closed surface is kini siya, sphere. Okay, so for a closed surface such as this one, The flux is positive for field lines that leave the enclosed volume. Okay, so the flux is positive for field lines that leave the enclosed volume, and it is negative for field lines that enter the enclosed volume. So if a charge is outside a closed surface, the net flux is zero. Since as many lines leave the surface, pareha na po ang number of lines nga mo-enter. Okay, so what does this mean? For example, kani class na kay, we can call this a Gaussian box. So there are three cases in which there is zero net charge inside a box. And kung zero ang net charge, wala po siya electric flux through the surface of the box. Okay? So, ang box class kay na siya ay pila ka surfaces? 6. So, na kay 1, 2, 3, 4, 5, 6 surfaces. And the first case is, kung wala sulod nga charge ang imong box, of course, wala na siya flux. Zero ang net charge, zero ang electric field, so zero ang net flux. Okay? Now, here is another case wherein naisulod nga charges ang box but the flux cancels out since pareha og magnitude ang imo ang positive charge and negative charge. Okay? So, ang number of flux nga mogawas will cancel the outward flux, the inward flux. Okay? So, again, sa ganito, ang electric field lines kay mo-emanate na siya from a positive charge and into a negative charge. So, maong na ay mogawas nga flux, gikan sa positive charge, and then, napoy mosulod nga flux or field lines due to this negative charge. Okay? And then, another case is, kung naa sa gawas sa box ang imo ang charge. Okay? So, walay naka-enclose nga charge sa imong box na siya sa gawas. So, naghapon kay electric field lines ani, but the number of field lines that is going inside the box is the same as that is going out of the box. Okay? So, zero ang net flux. Alright, so those are the three cases. Now, here is another quick quiz. So, for which of these closed surfaces, A, B, C, and D, the flux of the electric field produced by the charge plus Q is zero? Okay, so asa daw aning closed surfaces, we have initial A, and then this one is B, and then C, D. Okay, so asa ani, for which of these closed surfaces, zero ang net flux? Can you identify? Asa ni class? Okay, so based on the previous slide, si C, kaya nga naman, wala man siya naka-enclose nga charge, right? How about D? D also, wala pa siya naka-enclose nga charge. Si A, na-enclose niya si plus 2Q. And then si B also, na-enclose niya si plus 2Q. Okay? So, nani siya ay outward nga flux, kay positive man siya. So, this kinipod, napod ni siya outward nga flux. Okay? I mean, outward nga electric field lines. Pagawas nga electric field lines. So, ang flux is positive. Okay? The flux for these two surfaces are positive. Kaya nga ganito, ang A kay padulong diri, ang imo apong electric field lines kay pagawas, so positive ang imo ang flux. The angle is less than 90 degrees. But if the angle is greater than 90 degrees, then you will have a negative flux. Okay, so we have here a spherical surface with point charge at the center. Okay, so you have a positive Q charge here at the center, and then you have a spherical surface. So take note nga anywhere there is a surface class, ang distance ana from the center is of course equal to the radius r. Okay? Now suppose we get a very small area here, infinitesimal area dA here. So for this area, napun ni siya flux that is equal to dphi. And if we want to know the total flux for this spherical surface, we just have to integrate dphi. Okay, so you have this one. Phi is equal to, or the flux is equal to the closed integral of dphi, or this is equal to the closed integral of E dot dA. Okay, now for this, we have calculated this before, ang electric field ani class for a single point charge. A distance r from the charge is equal to this one. 1 over 4 pi epsilon naught q over r squared. Okay, so this is for a point charge. And then, so muna siyang electric field. And then your dA class is, nani siya gamay nga area that has, since we are considering a spherical surface, then it would be proper for us to use spherical coordinates instead of the Cartesian coordinates. Okay? So, kung Cartesian coordinates pa na siya class, your dA is just equal to dx times dy. Okay? But, kini, we are dealing with spherical surface. So, your dA for a spherical surface, kini siya diri where r is constant, no? So naman siya sa surface. So your r here is constant. It is equal to r sine theta d theta multiplied by r d theta. Or we can simplify it as r squared sine theta d theta dt. Okay. And then we integrate dA. So integrate na natong dA class. Integrating dA. So you have r squared sine theta d theta d phi. Integrating this will give us, so it will give us kani siya. Okay? So you have, i-copy lang nato ang constants, no? 1 over 4 pi epsilon naught. And then you have q is a constant. R squared is also a constant. So you have here r squared sine theta d theta d phi. Integral of r squared sine theta d theta d phi. And this is a double integral with respect to phi and with respect to theta. So you have this one. Cancel out actually ning r squared. So you have q over 4 pi epsilon naught. Integral of sine theta d theta from 0 to pi. So take note that your theta can only, so for a spherical coordinates, ang imong theta class kay murag kini lang ang iyang limit from here to here. And then your phi kay makatuyok siya from so kini siya from negative z to z. Ang imong theta, imong phi class kay makatuyok siya from diri sa positive x-axis pabalik. Okay? So, nakay limit nga 0 to 2 pi. Okay? So, i-show lang ni nako class, although dili ni siya necessary, but at least makabalo mo kung asa gikan tong 4 pi r squared. So, the answer for this, kining nakay sine theta d theta d phi, you will get 4 pi, then napakay r squared diri, you have, that is actually the surface area of the sphere. Surface area of the sphere, which is equal to 4 pi r squared. Okay, so if you integrate dA over all the area, ang imong makuha class kay 4 pi r squared. Okay, so you have this one. So q over 4 pi epsilon naught multiplied by 4 pi. So cancel out 4 pi. You are left with q over epsilon naught. Okay, so the flux is just equal to q over epsilon naught. Okay, so Gauss law is equal to that equation. So the closed integral, gikan siya sa flux class. So flux is equal to the closed integral of E dot dA, and it is equal to Q enclosed over epsilon naught. Now, this is for a point charge nga na ay nakasurround nga spherical surface. Okay? It turns out that bisan pag unsa ang shape sa imo ang surface class, kini siya nga equation is also true. So this equation holds true for any shape sa imo ang surface. Okay, so bisan pa og randomly kanang uh, random lang nga surface class, closed nga surface, ang imo ang makuha is kini gihapon, Q enclosed over epsilon na. Okay? So this means muna siya ang Gauss law. The electric flux through any closed surface is equal to the enclosed charge divided by epsilon naught. Okay? So this is Gauss law. This is always true for any surface, and occasionally it provides a very easy way to find the electric field for highly symmetric cases. Okay. Now you have this one. Calculate the flux of the electric field phi for each of the closed surfaces A, B, C, and D. Okay. So for surface A, ang naka-enclose sa iya nga charge is si kinis lang tolo. Plus 2Q minus Q si plus Q. And then for surface B, the enclosed charge is minus Q and plus 2Q. For surface C, you have minus Q and plus Q. And for surface D is only minus Q. Okay, so since we are to find the flux, and we know that it is just equal to Q enclosed over epsilon naught, then we just have to account the total charge that is enclosed by the surface. Okay, and then divide it with epsilon naught, which is a constant equal to 8.85 times 10. Yeah, to the minus 12. So epsilon naught is equal to 8.85 times 10 to the minus 12 coulomb squared per Newton meter squared. Okay? So for surface A, you have plus 2Q minus Q plus Q. So you have plus 2Q divided by epsilon naught. Okay, so that is the flux. And then for surface B, the flux is plus 2Q minus Q. So you have Q over epsilon naught. And then for surface C, you have a minus Q and a plus Q. So there is no flux since nag-cancel out ang charge. And then for the last surface, surface D, you have negative Q over epsilon naught. Okay? So there are two ways with which you can get the flux. The first one is using this equation, integral of E dot dA for a non-uniform surface or non-uniform electric field. You can also get the flux of a uniform electric field and plane surface by doing this. It is just equal to EA cosine theta. And then you can also get the flux if the charge enclosed is given. So you just have to divide it with epsilon naught. Okay? Okay, so here, calculate the electric field produced by a point charge using Gauss law. So for a point charge class, positive nga point charge, we know that the electric field lines or the electric field is directed radially outward, or it is moving or spreading out from the charge. And then for a spherical surface, for example, spherical Gaussian nga surface, Kung magkuha ka gamay nga area diri, for example, then the area vector is padulong diri ah. Okay, so it is parallel to the direction of the electric field. So bisag asa nga case ka magkuha og A, ang direction sa imong electric field line is always parallel to the direction of the electric field vector. Okay, so you have this one. Parallel siya, no? So you have E dot dA is just equal to E dA cosine theta, where your theta is, since parallel, theta is equal to 0 degrees. So you have, this is just equal to E times dA. Okay? So the flux is just equal to E times dA, or if i-account na to ang tanan, flux is equal to E times A. Okay, so take note of that class ha. Anywhere in the surface of your spherical Gaussian surface, kung positive ni siya, parallel. Kung negative imong charge nga nasa center, then anti-parallel, meaning to say 180 degrees. Okay? Kaya ano ganito? Because the electric field of a negative charge kay pasulod siya, no? Paana? Radially inward. Okay. So, we have this one. So, from here, we have, it is equal to, what is the electric field produced by a point charge? So, muna siya to ang first nga problem. Using Gauss law, we have to get the electric field produced by a point charge. So, we have E dot dA, integral of E dot dA is equal to Q enclosed over epsilon naught. So, if the charge inside our spherical Gaussian surface is equal to Q, then ang Q enclosed class is Q. Okay? So, you have this one. Now, we have taken out E sa integral because E is constant anywhere in the surface. Okay? So, kung dili ka magkuha ng surface, you will get the same value sa E kung dili ka magkuha or anywhere sa surface class. Since, of course, gikan sa center, ang distance niya anywhere sa surface is just equal to the radius. Okay? So, you have this one. Now, we have shown kaganina that the surface area of a sphere is equal to 4 pi r squared. So you have E multiplied by 4 pi r squared is equal to Q over epsilon naught. So the electric field is equal to this one. 1 over 4 pi epsilon naught Q over r squared. Okay? So we have obtained this one katong using Coulomb's law. So, di ba nag-start ta og F is equal to K or 1 over 4 pi epsilon naught Q1 Q2 over r squared. And we have also defined electric field as F over Q. So you just have to divide this with Q. Then you will get, if you divide this with Q, you will get this equation. Okay, so this is from Gauss' law. We have arrived the electric field produced by a point charge using Gauss' law. Pareha na siya og expression, of course, sa katong i-derive nato from Coulomb's law. Okay? Now, do you have any questions, class, so far? Okay. So, you can just read this one. Gauss' law gives us an easy way to solve a very few symmetric problems in electrostatics. It also gives us great insight into the electric fields in and on conductors and within voids inside metals. Okay. So Gauss law and Coulomb's law, the two laws are equivalent. Okay. So again, Gauss law class is always true, but it is only useful for certain very simple problems with great symmetry. Okay? So Gauss law, muna siya, the total flux within a closed surface is proportional to the enclosed charge. Now here is our application sa Gauss law class. So for example, you have here a positively charged sheet with surface charge density equal to sigma. And then for this infinite sheet of charge class, since it is positively charged, then ang electric field ani is away from the sheet. Okay? So sa right sa imong sheet, ang electric field is going to the right, or it is directed to the right. And then dili po sa pikas nga side, it is directed in the opposite direction. Okay? Now, in order to, ang atong goal class, nganong magamit ang Gauss law is to get the electric field due to this infinite sheet of charge at any point sa imo ang sheet. So, pwede ka din magkuha og point or diri sa pikas nga side. Okay? So, select the Gaussian surface. So, kasagara, ang ginagamit nato nga Gaussian surface is spherical Gaussian surface. Another is cylindrical Gaussian surface. Cylindrical Gaussian. So, depende sa orientation sa imo ang charge, no? And then, we have a Gaussian pillbox. Okay, so select Gaussian surface. So, in this case, a cylindrical pillbox or cylindrical Gaussian surface. Okay, so muna siya to ang Gaussian surface class. Ang Gaussian surface is just an imaginary surface. Okay? And then, calculate the flux of the electric field through the Gaussian surface. Okay, so we have tulo ka areas atong i-consider ani. Kung nakay cylindrical nga Gaussian surface class, tulo ka area atong i-consider kaning sa iyaang kining sa mga taklob, kani siya nga surface, kini siya nga surface, o kining sa body. Okay? Now, for this, nganong ang iyang flux is equal to 2EA. Ano kaha daw? So, dire, kini nga point, ang imong area is kining circular area. Ang iyang area vector class is pagawas, like perpendicular ani, no? And then your electric field vector is kining violet. Okay? So at this point, at this point sa surface, kining circular nga surface, ang imo ang flux is equal to E times A lang, since ang atong theta, the angle between the area vector and the electric field vector is 0. Okay? And then here, ang imong electric field kay padulong dito. Okay? And then, ang imong pong area vector class, since naman diri sa left side ang imong ang taklob, so, naapo diri imong area vector. Okay? So, this is the area vector. Ang electric field vector is the violet one. So, the flux ani nga area 1 is equal to EA. The flux at area 2 is also equal to EA. Okay? Now, kining sa body, ang imong electric field class kay kung ano no, rightward or leftward, But there is a body, ang imo ang A is padulong diri paana, murag pagawas sa lawas. Mura siya og like kung kini ang imo ang cylinder sa body class kay ingani ang imo makita nga electric field. Okay? So it is dili. This is the area vector rather. So bisag asa ka magkuha diri like diri magkuha kag area, ang imong area vector kay radial. Okay? So kung diri po ka magkuha like radial gihapon ang imong area vector. But your electric field vector is kuan lang siya. Na diri into the cylinder or out of the cylinder. So meaning to say kung mura siya ingani no, kung ingani mong area vector, ang imo ang electric field vector is perpendicular sa imong area vector. Therefore, for the body, the flux in the third surface is equal to 0. Okay? So the total flux is just equal to phi sub 1 and phi sub 2, which is equal to 2 times EA. Okay? Nakuha ninyo, class? This is for an infinite sheet of charge. Now, we equate this with Q enclosed over epsilon naught. And then solve for the electric field. Okay? So equating this with Q enclosed over epsilon naught, we can solve the electric field. So you have E is equal to Q enclosed divided by 2 times A times the permittivity epsilon naught. Okay, so you have here Q enclosed over 2A times epsilon naught. Now, your Q enclosed, remember, nga atong Q class can be dq can be written as kung ingani kung line kay lambda dl, kung surface you have sigma times dA. Okay? Now, so the Q enclosed, ang enclosed ani nga surface is just equal to sigma times dA, where dA is just equal to A. So, the area, kini siya, area ani nga, yung nakabutang diri nabutang niya diri class nga, ang area ani is just equal to A. So, it is just equal, if you integrate this from 0 to A, then dA is just equal to sigma times A. Okay? So, makancel out ni si A. Ipakita na to, no? You have E is equal to sigma times A divided by 2A epsilon naught. So we can cancel out A. So we are left with this equation. So sigma divided by 2 epsilon naught. Okay? So this is the electric field of an infinite sheet of charge. So ato siyang isulat para ma-emphasize. E is equal to sigma over 2 epsilon naught. Okay. So you have this one. For an infinite sheet of charge. You have to take note of this, class, para dili na ta magbalik-balik og solve ani. Okay? So, kung nakay problems nga mag-involve og infinite sheet of charge, then automatically, the electric field is equal to sigma over 2 epsilon naught. Okay. So, muna siya itong i-discuss ka ganina, no? Kung ang ibang system, kaya na siya spherical symmetry, then you have to use a spherical Gaussian surface. And then, kung napod siya line or cylinder, then you have to use a cylindrical Gaussian surface. And if it is a plane or a sheet, then you can use either the Gaussian pillbox or the cylindrical Gaussian surface. Okay. Now, take note nga, kung cylindrical, kung line gani sa class, ang say meaning ani, cylinder centered at the axis of symmetry. So, for example, na kay line charge that is vertical. So, muna imong line charge, positively charged siya. Ang imong cylindrical Gaussian dapat kay naa siya diri. Ang iyang center is kaning line. Okay? But, kung pareha sa atong problem kaganina, nga sheet man to siya, no? Plane, dapat daw ang axis o ang cylinder or ang pillbox, ang iyang axis is perpendicular to the plane. So, since vertical man ang ato ang infinite sheet of charge, then dapat naghigda ang ato ang cylinder. Okay? Naghigda siya dapat. And then, for example, kung ang imo ang plane is naghigda, then ang imong cylinder dapat is nagtindog. Okay? So, muna siya magtiman ang class. So, this is an example ng kay line charge. So, we know that for this line, kung positive ni siya, ang iyang electric field kay mag-spread out. So, pareha aning violet nga lines. Okay, so, kaganina, no, ang atong na-account kay kining duha ka taklob. Ang body kay wala siya flux. But this time, only the body has the flux. Kay kani, perpendicular ang area vector ug ang electric field. So, ang imong electric field kay na diri, ang area vector kay paana. So, perpendicular sila with respect to each other. Okay? So, walay flux diri nga area, wala po yung flux diri sa pikas nga side, ang naalang kay kining sa body. Okay. So, we have here a problem. A charge Q is uniformly distributed through a sphere of radius r. What is the electric field as a function of r? And find E at R1 and R2. Okay. So, you have here, sa siya kanang solid nga sphere, meaning dili siya hollow. Nani siya sulod sa tunga. Dili ni siya bola sa basketball but kuan siya kanang solid nga sphere. Okay? And the total charge of the sphere is Q. And it is uniformly distributed through the sphere with radius r. So the radius is r. We are to find the electric field as a function of r. Okay, we have 2 points to consider, r1 that is outside the sphere and then r2 that is inside the sphere. Okay, so for this problem, we have to solve first kining the points outside the sphere. So for this, since this is a spherical, this is a problem with spherical geometry, then we will use a spherical Gaussian surface. Okay, so this is our imaginary Gaussian surface. Dapat kay ang iyaang radius class kay pareha sa distance from the center of the sphere towards this point. So this is point R1. And say for example, ang iyang length pod kay equal to R1. Okay? So this Gaussian surface, kining broken lines, has a radius equal to R1. Alright, so we start with this. E dot dA is equal to Q enclosed over epsilon naught. Now, for this case number 1, where the point is outside the sphere. Okay? So, as you can see, ang na-enclosed na charge is just equal to the total charge, which is Q. Okay? So the total charge enclosed is just equal to Q. Therefore, you have E multiplied by the integral of dA is equal to Q over epsilon naught. Now, we know that the integral of dA for a spherical surface is just equal to 4 pi r squared. Okay? So, ingani ka easy ang Gauss Laplace. Although, naka-integral nga makita, but dali ra kayo siya makuha. Dili pareha atong ato ang previous nga examples last time nga taas kayo ang integration. Okay? So you have E, the integral at this point, the electric field at this point is just equal to 1 over 4 pi epsilon naught Q over R squared. Okay? Take note, class, that your R here should be the radius of the Gaussian surface. Okay, so since you are integrating dA, kini nga area man imong gikuan, consider. So you have to integrate this from 0 to R sub 1. Therefore, the electric field is equal to 1 over 4 pi epsilon naught Q over R sub 1 squared. Okay? So this is the surface area of the Gaussian surface. Alright. And then how about at points? Points outside. How about at points inside the sphere? So for points outside the sphere, for points inside the sphere, we have E multiplied by 4 pi r sub 2 squared is equal to Q enclosed over epsilon naught. Now, here comes kini siyang challenge, class, no? Take note that ang imong Gaussian surface is kanilang. Kanino? Dapat kay nasya sa sulod. Ang radius sa imong Gaussian surface kay parehag length sa distance from the center towards point R2. Okay, so this is your Gaussian surface, class. Now, take note nga, ang iyang na-enclose nga charge kay fraction lang dapat sa katong total charge Q, right? Kay wala man yan na-enclose tanan. Kani diri, na pa man ni mga charges diri Okay? So, your Q enclosed, where Q enclosed is equal to rho times dV. Okay? Or rho times V. So, we define here a volume charge distribution or volume charge density, which is equal to rho. That is, kung sa gato definition sa rho is equal to the total charge divided by the total volume. So, the volume of the sphere is equal to 4 pi multiplied by the radius of the sphere, kini nga sphere, r squared. R cubed. 4/3 pi r cubed. Volume, ha? So, volume, you have 4/3 pi r cubed. So, total charge divided by total volume, muna siya itong rho. And then, i-multiply siya nato sa volume sa Gaussian surface. Okay? So, the volume of this Gaussian surface, kining red nga Gaussian surface, is just equal to volume of the Gaussian surface is just equal to 4/3 pi r sub 2 cubed. Okay? So, therefore, ang atong Q enclosed is equal to, okay pa mo, class? Is equal to, i-multiply lang ni sila natong duha, class. So, So this is equal to Q divided by 4/3 pi R cube nga dako, R nga dako. And then, ang Gaussian surface is 4/3 pi R sub 2 cube. Okay? So we can cancel this 4/3 pi in the numerator. So we are left with Q multiplied by R sub 2 cube over R cube. Okay? So, as you can see, this is lesser than Q. Kaya naman, ang imong R sub 2 class, mas gamay man ni siya compared sa imong R. Okay? So, Q multiplied by R sub 2 cube divided by R cube. So, this is your Q enclosed. So, ato ni siyang i-substitute into our equation. Ano din yung solution kaso? Okay, so let us substitute this into our equation. So we have E multiplied by 4 pi R squared. This is R sub 2 squared is equal to Q enclosed over epsilon naught. So this is equal to E multiplied by 4 pi R squared is equal to, your Q enclosed is equal to Q multiplied by R sub 2 cube over R cube divided by epsilon naught. Or we can simplify this as E multiplied by 4 pi R sub 2 squared equals Q R sub 2 cube over epsilon naught R cube. Okay, so the electric field inside the sphere is equal to Q R sub 2 cube over 4 pi epsilon naught R sub 2 squared times R cube. We can further simplify this. Makancel out ning R sub 2 squared. Ang mahabilin na lang diri kay isa na lang ka R sub 2. So you have 1 over 4 pi epsilon naught Q times R sub 2 over R cube. Okay? So this is the electric field anywhere inside the sphere. So this is the electric field at any point inside the sphere. Okay? So you have to take note of this para di na mo balik-balik og solve kung na nga problem. Okay, again, ang electric field outside kay kani. So mura lang siya point charge, no? Nga ang total charge kay Q. For points inside the sphere, you have this one. The electric field is equal to this one. Okay, do you have any questions? So, muna siya ang iyang solution. So, this is for R greater than R. For any point outside the sphere, your electric field is equal to 1 over 4 pi epsilon naught Q over R squared. And for points inside the sphere, you have this one. 1 over 4 pi epsilon naught Q R over R cube. Okay? So, gisolve na ni siya nato class. So, this is the graph of the electric field. So, kung naang points diri napa diri, linear pa siya, pasaka. But, kung magawas na siya, magkaabot sa infinity, magkagamay. Okay. Or, kini nga ni siya. 1 over r squared. A function of 1 over r squared. Okay. So here is another problem. Look closer at these results. The electric field at the red point, comes from a sum over the contributions of all the little bits of squares. Okay. So it is obvious that the net electric field at this point will be horizontal. So the same with the line charge nga ato ang i-consider last time class, nag-cancel out ang mga y components. Ang mabilin nga electric field is along the x component, horizontal line. Sorry. So the magnitude from each bit is different, and it's completely not obvious that the magnitude E just depends on the distance from the sphere center to the observation point. So doing this as a volume integral would be hard, but Gauss' law is easy. Okay, so no, ingani atong approach tong miagi, nagkuha tag mga gagmay nga bits, tapos atong i-account ang mga small de's, de, and then ato ding i-integrate. Okay? So sa Gauss law, dali ra kaayo class, kanira ang solusyon. So at any point outside the sphere, it is equal to this. Any points inside, it is equal to, this is points inside, ang points outside kay kani. Alright. We have another problem here for an infinite charge plane. Okay, so consider an infinite plane with a constant surface charge density sigma. So what is the electric field at a point located a distance z above the plane? Okay, so imagine nga na kay sheet of paper that is positively charged. And then ang atong points nga i-consider is kini point blue, where it is a distance z above the plane. Okay. So, pwede rin siya nato gamitan og cylindrical nga Gaussian surface, which is parallel to the plane. Perpendicular to the plane. Pwede po siya nato gamitan og Gaussian pillbox. So, let us see kung sa'y gigamit niya. So, the electric field must point straight away from the plane if sigma is greater than 0. So, meaning to say, kung positive ang imo ang charge, if this is positively charged nga plane, then the electric field would be going to this one. But if it is negatively charged, then pasulod ang imong electric field. Okay? Maybe the magnitude of E depends on Z, but the direction is fixed. And A is independent of X and Y. So we can use symmetry for this. We can use a Gaussian pillbox. So for this, kay pila ka surfaces ang i-consider. You have this one, and paubos lang. Pasaka o paubos. Okay? Dili ni magmatter because ang electric field nimo kay perpendicular man sa area vector aning upat ka surfaces. Diba pila gani ni ang Gaussian pillbox kay pila gani niyang surface class? 1, 2, 3, 4, 5, 6. So the four surfaces kining nasa mga kilid dili ni magmatter because the electric field is perpendicular to the area vector at this point, no? So klaro kayo ang electric field, walay niagi nga electric field diri ang mga kining nasa kilid. Ang maagian lang nga area is kani pasaka og paubos. All right. Now we let the area at the top and bottom be A. So this is A. And then sa ubos pod, since this is a box, A pod. Okay? So the total charge enclosed by the box is just equal to sigma times A. Okay? So it is equal to sigma times A. And then you have two surfaces. The outward flux through the top. So kani, nakay mga flux paana. Ang area vector pod ani is paana. Okay, so you have a positive flux. Flux here is just equal to E times the area, EA. And then sa ubos, through the bottom, you have EA also. So, but the outward flux through the sides, ang yung flux is 0. So, anywhere ani. 1, 2, 3, 4 ka sides, 0 na siya. So, you have the total flux is just equal to 2 times E times A. 2EA. Okay? Now, Gauss' law says that Q enclosed over epsilon naught is equal to the total flux. So, you have this one. Cancel out A. So, you will get E. So, for a plane, pareha lagi po itong nakuha no, bisag kaganina nagtindog atong plane, kini siya kay naghigda ang plane. So, electric field, tapos ang ato po dyan gigamit kaganina class kay cylindrical nga pillbox. So, the same ra ato ang result. So we have cylindrical nga Gaussian surface. Kini siya kay Gaussian pillbox. Ang atong nakuha nga electric field is still the same. It is equal to sigma over 2 epsilon naught. And it is directed outward. Okay? So it is not dependent on the area of your Gaussian pillbox. Nga naman, nag-cancel out ang area class. So no matter how big or small is your Gaussian pillbox, you will still get the electric field equal to sigma over 2 epsilon naught. Okay? So the size of the Gaussian surface does not matter. Okay, now imagine doing this with an integral over the charge distribution. So you have to break the plane into smaller regions, no, like this one. You have to break it into smaller areas and then i-account na mo ang total electric field by integrating this. So this will take a whole lot of effort. Okay, but Gauss' law is easy. Okay, so we have 7 minutes left. Kini siya class, this will be your assignment. So the same with Chem 2A, this will be your assignment. Okay? And then, for conductors, kung naki-conductor class, we know that conductors are materials which charges can freely move. Okay? So these are usually metals. Now, the excess charges of a conductor is kuan siya, nalang siya sa surface sa conductor. For example, na kay spherical nga conductor. Okay? So the excess charges, like for example, this is a metal. The excess charges will reside only on the surface. Okay? Such that, for example, kung magbuhat kag Gaussian surface diri sa sulod sa imong conductor, if you want to know the electric field at this point, or at any point inside your conductor, the electric field there is equal to 0 because wala man ni siya kanang nag-cancel out ang mga charges diri a class. Na siya charge but equal ang number of charges, ang positive ug negative charges. Ang excess charges kay nag-reside lang sa surface na diri. For example, this is positively charged. So, nara diri sa surface ang charges. So, this means that for a conductor, the electric field inside or at any point sa mong conductor class, the electric field is equal to 0 because Q enclosed is equal to 0. Okay? Now, if you want to know the electric field at any point outside the conductor, you just have to make a Gaussian surface outside, enclosing your conductor. So here, ang imo pong electric field ani class is just equal to 1 over 4 pi epsilon naught Q enclosed over epsilon naught. Sorry, 1 over 4 pi epsilon naught Q enclosed over R squared. Okay? So, the same ra siya sa insulating sphere. But ang nag-differ lang sa ilang class is the electric field inside. Okay, so for conductors, the electric field is equal to 0 at any points inside because again, ang mga excess charges kay mag-reside lang on the surface. Okay, this one. For a charged conductor in a static situation, all the charge resides at the surface of a conductor. The electric field is 0 everywhere inside a conductor and perpendicular to the surface just outside. Okay? So ganito, ang electric field inside is equal to 0, but ang electric field just outside the conductor is perpendicular to the surface. So, na siya dito, perpendicular sa surface. Murag hapon radial gihapon ang direction sa electric field just outside the conductor. Okay? Now, why is E equals 0 inside a conductor? Here is the explanation class. Conductors are full of free electrons, roughly 1 per cubic angstrom. So, isa ka electron kada cubic angstrom. So, these are free to move. If electric field is non-zero in some region, then the electrons there feel a force that is equal to Q times E, where ang Q sa electron is equal to minus E times the electric field. So this is the force, Coulomb force, that is ma-feel ni electron. Now, in an electrostatic problem, the electrons adjust their positions until the force on every electron is 0. Okay. So, ilaang i-adjust ilang position until mabalance. No? The net force is equal to 0. The net force on every electron is equal to 0. So that means when equilibrium is reached, the electric field is equal to 0 everywhere inside a conductor. Okay. Since the electric field is 0 inside a conductor, ang sasulod dahil sa conductor class is neutral. Okay? So, suppose there is an extra charge inside. For example, na extra charge diri Gauss' law for the little spherical surface says that there would be a non-zero electric field nearby. But there can't be within a metal. So, ang gabuhaton class, kung naay sulod diri say for example, this is a conductor, and then naay hollow nga spot diri diha nga pwede nato butangan og charge. So ang buhaton sa conductor para 0 gihapon ang iyang electric field anywhere inside this conductor kay yan ang i-cancel out. So if this is positive Q for example, magbutang sa diri charge that is equal to negative Q para ma-cancel out ni siya such that 0 gihapon or neutral gihapon diri ang portion inside the conductor. Okay? So, let's see kung okay, hapit na dayon tatapas. But we do not have time na. So, we will continue this in the next meeting. And hopefully, we will have some kanang examples class. Kanang na mga values nga examples. Okay? So, for Chem 2A, i-upload lang nila ko nga video class. Dili ta mag-meet today. Tanawa lang ninyong video. Okay? Bye-bye. So, see you on Thursday.